This is a presentation about cross-curricular teaching of mathematics and science. This presentation will look at the history and cross-curricular teaching today. It will discuss the advantages and disadvantages and further analyze cross-curricular teaching in context of math and science. In addition, the presentation will analyze the use of ICT to enhance children's learning and its disadvantages. Cross-curricular approaches to teaching and learning is widely debated as an effective way to teach children. Comenius and Rousseau, among many other thinkers of the 17th and 18th century, believed that cross-curricular teaching had the purpose of helping children to interpret and understand their day-to-day experience of the world. In the 19th century, Froebel contributed to the idea of cross-curricular teaching by arguing that play had a huge role in child's education. Later, under the influence of Piaget and Vygotsky, many schools introduced scaffolded learning to move students progressively toward stronger understanding and ultimately greater independence in the learning process. Experiences chosen to be understood through a number of different subject disciplines exemplify the education philosophies and recommendations of 17th, 18th, and early 19th century philosophers like Comenius, Rousseau, or Froebel. The idea of child-centered education spread through the early 20th century, further influenced by John Dewey from the USA and Rudolf Steiner from Europe. Cross-curricular approaches were championed by different philosophers in their own ways. Nowadays, cross-curricular teaching and learning is believed to open up a narrowed curriculum and ensures a greater depth and balance. The 1931 Header Report encouraged teachers to let children explore different aspects of the world by using their own curiosity. Further, it strongly recommended that teachers should take a more thematic approach to enable pupils to develop more independent inquiry skills. Therefore, teachers were encouraged to plan in a more cross-curricular way. The Header Report states that the curriculum of the primary school is to be thought of in terms of activity and experience rather than knowledge to be acquired and facts to be stored. The 1976 Plowden Report stresses the emphasis on child-centered teaching and learning, children's own interest to influence learning and to understand the world around them, as well as their own role in the environment. The Rose Review in 2009 advocated cross-curricular studies as part of the whole curriculum, as they provide opportunities to develop good attitudes and dispositions to learning. The review argues that a combination of discrete subject teaching and cross-curricular studies would enable children to develop an understanding of both what to study and how to study. Primary schools have for many years, following recommendations of the Plowden Report 1967, organized the curriculum on a thematic topic-based structure. Now, looking at the advantages of cross-curricular teaching, different cross-curricular pedagogical methods can be seen as a way of supporting the varied and diverse abilities of pupils. In order to be able to allow pupils the opportunity to form a meaningful connection between subjects that better reflect the world, we need to apply themes across two or more disciplines. Cross-curricular teaching and learning leads us away from the notion of the teacher being a provider of facts. It emphasizes a pupil-led thinking and reasoning skills, creativity, investigation, and communication. In 2008, Boyle and Bragg conducted a longitudinal study over a period of 10 years. They found that if developing cross-curricular links, it would enable schools to develop a broad and balanced curriculum. Further, in 2010, Ofsted conducted a survey that evaluates and illustrates how 44 schools use creative approaches to learning. The findings were that cross-curricular projects contributed to developing a broad range of skills needed for later success, including the ability to work both independently and collaboratively. According to Muse and Reynolds, a cross-curricular teaching and learning approach provides a more realistic learning environment for pupils and allows independent exploration of topics. This topic-led approach can increase engagement of children. Now, analyzing disadvantages of cross-curricular teaching, the NSTA found that teachers lack time and confidence to plan thoughtful connections in the curriculum. Hayes argues that learning needs the clearly delineated boundaries provided by single subject teaching. In addition, according to Alexander, Rose and Woodhead in 1992, there is insufficient evidence to suggest that the cross-curricular approach enhances children's learning. They class the cross-curricular approach as superficial teaching and learning. They should suggest that an independent approach to subject is more beneficial to a child's learning experience. In this part of the presentation, we will look at cross-curricular teaching in context of math and science. Math and science are inextricable. Measuring, comparisons, observations, and recording are skills that have to be learned in both subjects according to the national curriculum, so why not teach them both together? In 1999, Peterson recognized a connection between mathematics and science. There is a need to use mathematical skills in science investigations. He states neither math nor science are trivialized. Measuring length, weight, or capacity involves the ability to read a number line in a science context. This gives a greater motivation to the children. On one hand, science can provide a great opportunity to practice a range of mathematical skills within an engaging context. On the other hand, numbers enable young children to talk about their science, explaining their findings, so their beginning to count is intrinsic to their understanding of the world. When planning lessons, the teacher needs to remember that the aim of the science lesson is to develop pupils' scientific knowledge while providing opportunities to apply learning from mathematics in a scientific context, where science can be used as a vehicle within mathematics for making skills learning real. Therefore, linking the subjects promotes meaningful learning in each subject. According to Feasey and Gallia, science is at the heart of mathematics. Science strongly relies on mathematics to provide quantitative evidence which can be used for comparisons, note patterns or trends, and draw conclusions. In the same way, school science relies on children's understanding of mathematics. A huge number of areas in science rely upon the use and understanding of mathematical concepts, such as data and graphs, patterns, ratios, fractions, or equations. According to Kelly and Steed, math is found throughout science. Cross-curricular teaching helps to appreciate the relevance of science and math ideas and skills. Lastly, we will discuss the use of ICT and its disadvantages. Technology gives pupils many ways of enhancing their learning. Most primary classrooms provide a whiteboard and other technologies. The nature of teaching has changed due to the huge availability of ICT. The use of ICT in lessons enables pupils to move out of the classroom. A research undertaken by Bechter has shown that the use of ICT in math, for example, encourages interactions between pupils. Pupils show increased cooperation skills and enthusiasm. Especially for math and science, technology gives the advantage of portable devices, which can be used to record data and present them in a much quicker way. Other technologies, such as iPads or laptops, can be used to look for information. Pupils can go beyond what is accessible in the classroom and gain access quickly and easily by using search tools. In addition, pupils can present their information in ways that engage other pupils, stimulate discussions and engagement in the topic by creating PowerPoint presentations or putting information on a social network site. ICT elements can further be used to broaden pupils' horizon. If pupils have never had the chance to travel, they can explore places by using Google Earth. However, technology, when not used appropriately and with care, can create issues and lead to misuse. Therefore, when using ICT in lessons, there are factors that need to be considered. Some critiques are concerned that the excessive use of internet, for instance, hampers children's ability to gather information in a discerned manner. Further, it is argued that ICT use also has prompted fears from imminent declines in children's cognitive skills, as well as the unbalancing of their hormone level and declines in mental performance. All mentioned facts considered, cross-curricular teaching has been primarily linked to creativity and innovation in primary schools. Thematic teaching promotes creativity and allows children to make connections and links between different subjects, which can enhance understanding, produce original questions, unique ideas, bringing their own connections to the lesson. As cross-curricular work allows two subjects to be mixed together, this can enhance a teacher's ability to be creative and enhance their student first-hand experience. Further, ICT can be used to enhance children's learning, but needs to be integrated with care due to the aforementioned risks, such as excessive use of internet.